So this is part 2 of question 4. So in part 1 we found the equation of BC, which is y equals minus a half x plus 13.5. So we asked to find the coordinates of C, which is this point here. So whenever you have to find a point that is the point of intersection between two lines, you have to get the equation of both of those lines that are intersecting at that point and solve the equation of those lines simultaneously. That's the only way to find the point where those lines meet, which in this case is point C. So we have the equation of BC already. We now just need to get the equation of AC, and then we can solve those two equations simultaneously. So remember, to get the equation of any straight line, you first need its gradient, and you also need a point on the line. So for AC, we already have 2 points, so we can choose any of these points as x1, y1. So for example, we could take x to be x1, y1. So we'll say that's 4, 4. But now the gradient of AC is basically going to be the same as the gradient of AX. So we can get the gradient between these 2 points in order to get the gradient of AC. So the gradient is change in y over change in x. So change in y, we can say 4 minus 3 over change in x, which will be 4 minus 1. So this is going to be 1 over 3. So now we have the gradient. We have a point on the line of AC. We can now use the formula or equation y minus y1 is equal to m times x minus x1. And we just sub these values in and simplify to get the equation of AC. So we have y minus y1, which will be 4, is equal to the gradient, which is a third, x minus x1, which is 4 as well. And now we just simplify. So this is going to be equal to a third times x is a third x. A third times minus 4 is minus 4 over 3. And then we get rid of minus 4 on the left-hand side. We add 4 to both sides. So we have a third x. And then we have minus 4 over 3 plus 4, which is plus 8 over 3. So this is the equation of the line AC. So now that we have both of these lines, we can now set them equal, or in other words, solve them simultaneously in order to find the coordinate of C. So we have the equation of BC as minus a half x plus 13.5, and we're making that equal to AC, which is a third x plus 8 over 3. And now we just solve for x to get the x coordinate of C. So get all the x's to one side. So I'm going to take all the x's to the right and bring all the constants to the left. So we have 13.5 minus 8 over 3 is equal to a third x plus a half x. So this left hand side will come to 65 over 6 is equal to 5 over 6 x. And now we just divide both sides by 5 over 6. So we get x is equal to 13. So the x coordinate of C in this case is 13. So all we're going to do now is just take 13 and we can sub it into BC or into AC. Because those two lines meet at the same point when x is 13, they'll give the same y values. So let's use the equation of BC to find our y value for C. So we can have y is equal to minus a half x plus 13.5. So you have minus a half times 13 plus 13.5, which is going to be minus 6.5 plus 13.5, which is 7. So C has the coordinate 13 and 7. So it's 13 and 7. And that's the coordinate of C.